Question 8. When an acidified solution of sodium nitrite NaNO2 is added to aqueous potassium iodide, iodine and nitrogen monoxide are formed, give the oxidation state of nitrogen following species. Species meaning element, atom, ion, anything. Don't be intimidated by the word species. So NO2 minus, well, we know the overall charge is -1. NO2, give the oxidation state of nitrogen. So well, oxygen is -2. -2 times by 4 is -2 times by 2 is -4. Therefore, what do we add to -4 to get -1? +3. NO, that's going to be +2. That's pretty simple. Oxygen by itself is -2. Overall charge of any compound like this with no charges is 0. Therefore, -2 plus 2 will give you 0. Therefore, oxidation state of nitrogen must be +2 in NO. 8.2, write a half equation for the conversion of NO2 minus an acidic solution NO. For this, before I carry on, for 8.1, you do need to learn specific rules of oxygen, hydrogen peroxide, and all of that. And that you just need to memorize it, maybe do a bit of practice. But then the general, I feel like they will test you on that. And that's why I was wary and I took my time in answering these questions. Otherwise, I could have sped run it and could have done it pretty quicker. But yeah, one thing I would recommend for the oxidation states, learn the key special cases that where it's not the general rule is not applied. So then it says 8.2, write a half equation for conversion of NO2 minus, that should be minus a bit higher, into NO. Well, first things first, we have 2 oxygens here. Now you might be wondering, well, put a 2 here, but then we get 2 nitrogens there. So what we're going to have to do is we're going to have to add a water molecule, add H2O, that's perfect, because that will give me 2 oxygens now on the right hand side. But it also gives me H2, 2H+, so then I need to add 2H+ on the left hand side. So we can only add water molecules and H+ and electrons, right? So now the overall charge on the left hand side is -1 plus 2, which is +1. So therefore I need to add an electron to give an overall charge of 0. So E minus plus 2H plus NO2 minus arrow NO plus H2O. NO plus H2O. And then write half equation conversion of I minus into I minus arrow I. Well, there's 2 iodines here, you need to have a 2 here. But now there's -2 charge here, and there's 0 overall charge of 0 here, so you need to add 2 negatively charged electrons. 2I minus arrow I2 plus 2E minus. 2I minus arrow I2 plus 2E minus. And then it says write an overall equation for the reaction of NO2 minus in an acidic solution with I minus. Now for this, what we have to do is couple these 2 previous equations together, so 8.2 and 8.3. So what do we notice is that we have 1 electron here and we've got 2 electrons here. So what we're going to have to do is, because we want to get rid of the electrons, right? So we're going to have to times the first equation by 2. So yeah, let's do that. Why are we wasting time? Let's do that. So it's going to be times this whole thing by 2. So what are we going to get? Let me just write it here. 8.2. 8.2, and we're going to times it by 2. So we're going to get 2E minus plus 4H plus. You have to times the whole equation by 2, not just left hand side, plus 2NO2 minus. That's a trap that I was about to fall into, but I saw the mark scheme and realized I'm not supposed to do that. Arrow 2NO And then the equation from 8.3, we're trying to add them together, couple them together. And now what we realize is, because we times equation 8.2 by 2, we have 2 electrons now, and therefore the electrons in 8.2 and 8.3 will cancel out. And now we just add them all up. So we get 2i minus plus 4h plus 2NO2 minus arrow 2i minus plus 4h plus 2NO2 minus arrow 2NO plus 2H2O plus I2. Can you divide by 2? I thought we would, but the iodine is, there's no 2 moles of iodine, so therefore we can't. So it's going to be 2i minus plus 4H plus 2NO2 minus arrow 2NO plus 2H2O, and we can't divide by 2, therefore we have to leave it like this. We don't want a half of iodine. So 2NO2 minus plus 2i minus plus 4H plus arrow I2 plus 2NO plus 2H2O. Do the charges balance out? Yes, the charge on the right hand side, overall charge on the right hand side is 0, and the overall charge on the left hand side, 4 plus 2 minus 2. No, 4 plus minus 2, that's 2, and then 2 plus minus 2, which will give us 0. So it's correct. And then it says, state the role of NO2 minus in the reaction with I minus. Well, the role of NO2 minus is an oxidizing agent. Oxidizing agent. Acceptor, electron acceptor / gains electrons. Then 8.6, in aqueous solution, nitrile ions react with acidified chlorate 5 ions according to equation. A 25 centimeters cube sample of an aqueous solution of sodium nitrate required 27.40 centimeters cube of a 0.020 mole per dm minus cube solution of potassium chlorate 5 for complete reaction. Calculate concentration gram per dm minus cube of sodium nitrite in the sample for 4 marks. First thing we're going to do, what is sodium nitrite? What are we trying to find in the sample? It's going to be this. The nitrite ions react with acidified chlorate ions in the equation. So we're trying to find the concentration of this. But obviously sodium nitrite is NaNO2. Okay. So first things first, we're going to have to find out the moles of the chlorate ions. So the moles of this, well, it's going to be mass. No, we're not going to do that. We're going to do concentration time by volume. It's going to be let me just read it again properly. Yeah, 0.0200 times by 27.40, but we need a moles per dm cube, so divide by 1000 of, it's better to label it, because last thing you want is you did all of the hard work, you got the correct answer, but you didn't label which one's the ions, and then, or you did all the hard work, you're about to work out the answer, but you don't know which mole's which. You just forgot due to pressure, you got nervous because of time pressure. So we've got the moles of ClO3 minus, and we know there's a 2 to 5 molar ratio between ClO3 minus and NO2 minus. So what we're going to do to find out the moles of NO2 minus, well, it's going to be this moles ClO3 minus divided by 2 times by 5. So 5.48 times by 10 to the power minus 3. Just do it one step. Don't just do divide by 2 times by 5 at the same time. So divide by 2, then times by 5 in your calculator. equals equals, and you get the moles as this. No 0.0137. Okay, and what we're trying to find is the concentration of sodium nitrite in the sample. So moles is equal to concentration times volume. Concentration is equal to moles divided by volume. So 0.0137 divided by the volume. And we know the total volume of the sample of aqueous solution of sodium nitrite is 25 centimeters cubed. But we want it in moles per DM minus cube, so we're going to do 25 times by 10 to the power minus 3, aka divided by 1000. That will give me 0.548. Is that the final answer? No, because that is the of nitrite. We're trying to find of sodium nitrite, and the MR of sodium nitrite is what? NaNO2. So Na23 plus NO NO2 plus 14 plus 16 plus 16, 69. So 0.548 times by 69, which will give me 37. No, it's not 0.548, it's 0.0548. No 0.0137 divided by 25 times by 10 to the power minus 3. 0.548. So I must have done something wrong. Maybe I calculated the moles wrong. 0.0200 times by 27.40 divided by 1000. 5.48 times by 10 to the power minus 4. Okay, must have just misplaced 100 or instead of 1000 or something. But therefore, that's minus 4, so you get 0.00137. So you get 0.00137 divided by 25 times by 10 to the power minus 3. 0.0548. 548, and therefore the concentration is going to be that times by 69, finding grams per DM minus cube. 0.548 times by 69, 3.7812, so 3.78 grams per DM minus cube. Sorry for that very silly mistake. I typed it too fast on my calculator. That's probably the reason, because obviously the calculator probably going to work it out wrong. Just typed in wrong. But you get hopefully you get the idea of how to approach this question. Find the moles of chloride ions, find the moles of NO2 minus is 2 to the 5 molar ratio. And then what we can do is we could find out the concentration, moles of concentration of volume, concentration moles divided by volume. And then therefore to find the concentration of sodium nitrite is NaNO2. We need to times it by the MR of NaNO2, which is 69, and that will give me 3.78 grams per DM minus cube for the concentration of sodium nitrite. And that is the end, question 8.